In Java, threads are a fundamental concept that revolutionized multitasking. Before threads, we relied on processes, which are independent programs running in their own memory space. While processes made multitasking possible, they had significant drawbacks. High overhead, as each process requires its own memory and resources, and slower context switching, as switching between processes is time-consuming and inefficient. Threads, introduced in Java, are lightweight and designed to solve these problems. They allow multiple tasks to run concurrently within a single process, sharing the same memory space, which leads to better resource utilization and faster execution. Before diving into threads, it's essential to understand a few foundational concepts. A procedure is a set of instructions or code that performs a specific action within a program. For example, a function or method is a procedure. Think of it like a recipe that tells you how to perform a task step by step. A process is an instance of a program in execution. It's a flow of execution that runs independently with its own memory and resources. A process could be anything from running a simple command to executing a large application. The processor, or CPU, is the hardware component that executes the instructions and generates processes. It handles the execution of multiple processes by allocating resources like memory and CPU time. In a single process system, one process runs at a time, and tasks are executed sequentially, one after the other. This increases execution time and reduces performance because only one task can be performed at any given time. In a multi-process system, multiple processes can run concurrently, and tasks are executed in parallel, which can reduce execution time and improve performance. However, multi-process systems still have limitations, primarily due to context switching. Context switching occurs when the system switches from one process to another, and it comes with overhead, leading to slower performance. Threads are the next step in the evolution of multitasking. They are lightweight, sharing the same memory space within a single process, which makes them more efficient. Switching between threads, called lightweight context switching, is faster compared to switching between processes, known as heavyweight context switching. Threads allow multiple tasks to execute simultaneously within a single process, leading to improved performance and resource utilization. Since threads share the same memory space, they can communicate and share data more efficiently than separate processes. Think of a process as a single lane on a highway. Only one vehicle or task can drive through at a time, and each vehicle has its own lane or memory. This is slower and more resource-intensive because each process operates independently. A thread is like a car on the highway. Multiple cars or tasks can share the same lane or memory, moving efficiently. Threads can switch in and out of execution quickly, making multitasking much more efficient.
Java applications can use either a single-threaded model or a multi-threaded model. In a single-threaded model, one thread executes at a time, and tasks are handled sequentially, leading to increased execution time and reduced performance. In a multi-threaded model, multiple threads execute at this time, and tasks are handled concurrently, which improves performance and reduces execution time. A process is a heavyweight entity. It has its own memory space, requires more resources, and takes more time to switch. Processes run independently from one another. A thread is a lightweight entity within a process space, making them more efficient for concurrent execution. Thread switching is faster, which improves the application's lighter and share memory within the same process, reducing the overall system load. Switching between threads is quicker compared to switching between processes, which means less overhead, like memory, making communication between threads faster compared to communication. Context switching is the process of switching from one task or thread to another. It is crucial to understand the difference between heavyweight and lightweight context switching. Heavyweight context switching happens between two processes and is more resource intensive, resulting in slower performance. Lightweight context switching happens between threads within the same process and is faster and more efficient, resulting in better performance. Let's take an example of a web server handling multiple user requests. Without threads, handle each one by one, which would be slow and inefficient. With threads, the server can handle multiple requests concurrently, improving. Java uses threads to optimize execution of applications, particularly those requiring concurrent tasks like user interactions, I/O background processing. Threads allow Java to improve responsiveness, as tasks like user background process or network requests can run simultaneously, making the app more interactive. They also enable efficient resource sharing, as multiple threads within a process share the same memory space, making the communication faster, and they can handle long-running tasks without blocking the main program. In conclusion, understanding the evolution from processes to threads is essential for mastering Java's concurrency model. Threads allow for efficient multitasking, leading to faster execution and better resource utilization. Applications that are not only more responsive, but also highly performant. Whether you are building web servers, real-time applications, or data processing systems, threads are a core concept to help you design efficient Java applications.